All right, so let's get started. I say draw a picture to get going. When we get to the harder ones, pictures will be even more necessary. So let's just kind of sketch a picture out, and your picture doesn't need to be to scale. Like for example, a 5-degree angle, right? Like that is so small, it can be kind of hard to draw. So that looks probably more like a 30, but I'm just going to label it with a 5 degree right there. Anyway, so you've got a 5-degree angle, and then you've got since they called A. Since 20 is labeled as A, that means that would be the length opposite to that 5-degree angle. Let's see. Go. All right, we'll just say 20 there. Whoops. There we go. And then, where would the 35 be? And so I can see in my picture that 35 would have to be down here since my 20 is looking a little shorter there. And so I would say angle B would be up here, and then angle C here, and then side length C here. Okay, so as soon as we solve for angles B and C and side length C, we can be done. Okay, so looking at the law of sines, I'm just going to go ahead and write it out here. Hopefully you have it memorized. You'll be happy later when we have more to memorize that this one's nice and locked in, okay? So let's just substitute things we have values for, right? So like we have a value for angle A. Let's put 5 degrees there. Remember to put the degree symbol, otherwise it's assumed to mean radians, and we super don't mean radians. We know side length A, my friends, is 20. Let's go ahead and replace that. And this, my friends, is called a complete ratio, okay? And these are absolute gold when it comes to this type of problem. So this is a complete ratio. We like those, okay? And then let's see, sine of B, we don't know angle B, but we do know side length B is 35. And so here you have a partially complete ratio, and then my C ratio is completely incomplete. Completely incomplete. How do you like that? Anyway, so the point is this: take your complete ratio and set it equal to whatever partially complete ratio you have, and then use that to solve, okay? We're gonna have you do most of the solving on paper. And so for example, here, you could kind of do cross multiply and divide, and so, or use cross products, whatever works for you. So I'll just go ahead and show cross products. Most people are usually pretty comfortable with those. So 20 times sine of B would equal 35 times sine of 5 degrees. And then we'll just divide both sides by 20 to isolate sine of B. And now it's time to punch things into your calculator, okay? So now that you've got B nice and solved for, make sure that your calculator is in degree mode. It's probably in radians from whatever we've done last. Anyway, so just do 35 times the sine of 5. Make sure you're in degrees mode so it knows you mean degrees, and then divide that result by 20. And then I'm going to go ahead and say is approximately equal to 0.15, and then the 2 could be rounded to a 3. Okay, you want your final answers to be accurate to the thousandths place. Now, because I'm probably going to use this for my next calculation, I'm going to leave the non-rounded version on my calculator. And then I'm going to go ahead and solve for B by taking the arc sine of both sides. So B would be, actually, let me show that step for anybody that's unfamiliar. You're going to take the arc sine to undo sine, since after all, that's what it was made for. Oops. And then you take the arc sine of that 0.153 business. Okay, so you'll end up with B being approximately, so do arc sine and then answer, which is like your negative key, but you push second and then your negative key. And that way you don't have that extra round off error because you're using what your calculator had with all the details there. Okay, and then this would be degrees. There you go. So now I have solved for angle B. Okay, and you can always add it to the figure if you'd like. But now let's figure out, okay, well, now we know that, how are we going to get angle C? Well, you could do law of sines again, or you could figure that you know 2 of the angles in a triangle, and all 3 should always add up to 180. So I hope it makes sense that angle C would be basically 180 degrees, take away the 5 degrees for angle A, and then take away the 8.773-ish stuff, okay? So you could just do 180, take away answer, and then take away 5, and you'd end up with 166.227, it looks like, degrees. There you go. But now I wrote that rounded to the thousandths place on my paper, but on my calculator, I have the extra decimal details that come after the thousandths place. So I have more detail than this on my calculator. Okay. So now let's figure out what side length C would be. And so I recommend you always go back to whatever complete ratio you had where you wouldn't have any round off errors or gross decimals to enter in. And then now we can know that that would equal sine of angle C divided by side length C. And then you use cross products again. There you go, or cross multiply and divide, whatever you do there, and then figure it out from there. So I'm just going to take the sine of my answer that's still sitting on my calculator and then multiply it by 20 and then divide that result by the sine of 5 degrees. There we go. And we'd get side length C would be approximately 54.633, it looks like. Okay. All right. So let's go through and box all of the things that we found. So we found side length C, we found angle C, and we found angle B. There we go. All right, my friends, hopefully that makes sense. For part B, we're going to have you do the same kind of thing, but let's make sure you remember how to use degrees, minute, second notation. All right, so let's give you angle A is 15 degrees and 40 minutes. Let's give you angle B is equal to 8 degrees and 15 minutes. And then side length B equaling 4.8. There we go. All right, see if you can solve that triangle. Good luck.